Let's take a look at another example where we are simplifying using double angle identities. So I want to simplify this expression, 3 cosine of theta sine theta, using a double angle identity. Well, if I recall my double angle identities, one of them kind of looks like this, that has a sine and a cosine. I remember that sine of 2 alpha is going to equal 2 times the sine of alpha cosine of alpha. Well, that's similar to this, but this is a 3 cosine of alpha. Let's think, what can I do to manipulate this to look like this? The 3 isn't very helpful, so what I would really like to have is I'd like to have 3 times 2 cosine of theta sine of theta. But now I can't just do that. I can't just stick a 2 in here. Effectively, I'm doubling this whole equation. I can only do that if I account for that by offsetting it with the multiplying by 1/2. So effectively what I've done here is I've just kind of manipulated how this looks without changing the value. Right? So I multiplied by 2, but I also multiplied this by 1/2. So that's okay. Why is that good? Well, because this inner part is sine of 2 alpha. So that means that I'm going to be left with 3 times the sine of 2 alpha, or theta, excuse me, times 1/2. And then I can combine 1/2 and the 3 together. So we'll say this all simplifies to 3/2 times the sine of 2 theta. A little tricky there. All right, for this next one, this one's going to be a little bit simpler because as I'm looking at this, I'm seeing there's a cosine squared theta, a -1 kind of thing going on here, but it's a little bit off. Well, I can factor out something from this expression. I can factor out a 2. So if I factor out a 2, this is going to equal 2 times 2 cosine squared of 2 beta minus 1. All right, now what's strange about this is I already have a double angle in here. This would be a whole lot easier if this were just 2 cosine squared of just one thing, and then I could apply the double angle identity here. I don't have just one thing. I have 2 beta. But still, the process is all the same. If I think about my identity that the cosine of 2 times something, or maybe rather than using an a, why don't we just think of this as the cosine of 2 times a thing is going to equal 2 cosine squared of the thing minus 1. Well, it turns out that in this case, the thing inside that box could just be 2b and 2b. Well, right over here on this right-hand side, I have what is inside of my parentheses here. So I'm going to substitute it with this whole piece. So really, this is cosine of 2 times 2 beta. So this will actually boil down to 2 times the cosine of 4b. I guess not beta, that's just a b. So this one's a little bit trickier because we end up coming up with 4 times an angle rather than a double angle, but we still use a double angle identity to get there. And really that should make sense because like the double, if I wanted to double 2b, I do get 4b. So it's still like a double angle. It's just that my angle doesn't start at b, it starts at 2b. So it's the same type of idea, just using kind of different values in there, but a little bit tricky. Why don't you pause the video and give this one a shot. Again, very similar to the last problem, so review that if you need to, and see how this one goes. All right, and here are my solutions for these two.